So now we're going to look at production order quantity model. So here is how the inventory on hand will look like. Now we start with a production order starting. Batch of production gets started and the order quantity is delivered staggered over a period of time. So this is the time span during which production will take place. Now during this time period there will be order quantity coming into inventory at the rate of production, and at the same time there will be demand for the products and the demand will be going out. So the increase in inventory is not going to be instantaneous like in the previous case going all the way up to Q, but it's going to increase at the rate of the production rate minus the demand rate. So P minus D. P is the production rate, D is the demand rate. So during this time there will be demand for the product and some of the inventory will be going out. So the maximum inventory level is not going to be equal to Q as in the previous case. It's going to be slightly smaller. So we have to figure out what that maximum inventory level will be. Now once the production phase is complete, so there is no more incoming inventory. So there will only be demand and the inventory will start declining. So it will go down and then the whole process will repeat. Now this time the average inventory is not Q over 2 because the maximum inventory level is not Q, but it is the maximum inventory level is this. So this point divided by 2 would be the average inventory, and that's the reason why the EOQ formula under the production order quantity model is going to be slightly different because the average inventory is different now. So Q is the order quantity for which we want to develop a formula, and H and S are like before. H is the holding cost, S is the setup cost. Now P is the daily production rate and D is the daily demand rate, or it could be weekly or whatever the periodicity may be. So P is the production rate, D is the demand rate, and T is the length of production in weeks or days or whatever it may be. So the average inventory level times the holding cost will be your annual inventory holding cost. The average inventory is going to be maximum inventory level divided by 2, not Q over 2 like in the previous case. So the maximum inventory level is the total production during the production phase minus the amount of inventory that would have gone out because there was demand also. So P times D is the total production quantity. Take away the demand that occurred during that time period, so D times D. So P minus D, the whole thing times T, is the maximum inventory level. Okay, so that is the maximum inventory level, and that divided by 2 will give you the average inventory. So now if you put everything together like in the previous case, setting the ordering cost equal to the inventory cost. Okay, so now the holding cost will be this Q over 2. If you plug in all the values and work it out, and this is what you will get. So now use this in our production model, and your Q is going to come out to be this. So square root of 2 times D times S over H like before, and then you have to adjust for the fact that the maximum inventory level is not Q over 2 anymore, so you have to multiply the denominator by this factor. Now if you look at this model, you will note that the production rate must always be greater than demand rate for this to make sense, because if P is equal to D, so you get 1 minus 1 will be 0 in the denominator, so that's no good. So that is, if the demand rate and the production rate are same, so that means you have to keep on producing and production will go out, so inventory will never rise at all. So you have like an infinite order quantity, keep producing the same part all the time. Now if P is smaller than D, then you get a number 1 minus a value that is greater than 1. So you end up with a negative number inside the square root, which is also absurd. So in that case, your demand is larger than what you're able to supply. So there is no question of order quantity. You have to keep on producing without stop. Only when production rate is larger than D, then you would produce at a rate larger than the demand rate. So your inventory will go up and you will reach a point where you'll stop the production and maybe produce some other item. And while the inventory of this item declines, then you can come back after a later time period and start another batch of this product. So for production order quantity model to work, P, the production rate, must be greater than the demand rate. Not equal, not less than, but greater than the demand rate. So here is an example. So given all the values D, S and H like before, in addition P and D, plug in the values and you get your production order quantity.